Hi guys, this Nico Black Vertex King of Buggy was given to us. The best part of the story is that it doesn't work and it has plenty of room inside. So it's the perfect vehicle to show you an alternative micro RC conversion method which uses off-the-shelf Arduino components. Let's get started. But what is micro RC? Frequent viewers may know it. If you don't know, have a look at the playlist above. The custom-made board is very small and even fits inside a Coke can car. Of course, it can also be used for bigger models. The original 620 mAh nickel-cadmium battery pack is still in good shape and can be reused. First we want to have a look at the TB6612 FNG motor driver datasheet. As you can see, it's able to supply a current of 1.2 amp long term and 3.2 amps short term. This is per channel. However, if both channels are in use simultaneously, the current is limited and the heatsink may be required. First we want to make sure that the carbon brushes are clean. Then we measure the cable resistance, which will be subtracted later. The motor is then connected. Then we search for the point with the smallest resistance. Please note that the axle should not move during the measurement. So this motor has an internal resistance of 0.7 ohms. So according to Ohm's law, it will draw 7.4 amps at 5.2 volt battery voltage. This is too much for our TB6612 FNG motor driver. But luckily the motor in this car only draws about 2.5 amps. This is fine if we wire both motor driver channels in parallel. But what if your motor draws too much current? Then you can use a standard ESC like this one and wire it to the Servo port 3. Or maybe you want to use a brushless motor. Then buy something like this. The components on this picture are required to do the conversion. Because of its USB port, I recommend to use a Pro Micro for debugging. Afterwards, I recommend to switch to a Pro Mini. It has more analog inputs and allows us to connect our battery voltage measurement voltage divider resistors. Afterwards, it should look like this. It's not pretty, but it works. The schematic can be found on GitHub. This is a top view, without the Arduino and the radio module plugged in. Here you can see how to mount the voltage divider resistors for the battery voltage measurement. This is how it works for the Pro Micro. Please make sure that you have selected SparkFun Pro Micro 3.3 volt 8 MHz. The Pro Mini is a bit more complex. We have to burn the modified bootloader first. It can be found on my GitHub. I strongly recommend to do it, because it lowers the brownout voltage to 1.8 volt. The bootloader is now uploaded and we are ready to upload our sketch. As you can see, a 3.3 volt 8 MHz Pro Micro is used as Arduino as an ISP. For more information on how to wire everything up and how to upload your program, have a look at the manual on GitHub. The link is in the description. The servo end positions and many other things can be adjusted inside the vehicle-config.h file. For example, you can configure headlights, brake lights, indicators, and even a self-balancing option is available. The top speed and the acceleration can also be adjusted for operation mode 1 and 2. After the configuration was changed, you have to re-upload your program. The servo travel can also be adjusted on the transmitter. Looks like the steering works just fine. Now the motor driver is wired and mounted. As you can see, both motor channels are wired in parallel. The wiring is now finished and the Pro Micro is replaced with a Pro Mini. Time for the final bench test. The dust cover can now be mounted. Not bad for the TB6612 FMG motor driver. Now let's switch the gears to the off-road mode. The gears are now back in on-road mode. Will it still work in the grass? Now it's a little bit too much. And yes, of course you can also build a transmitter out of prototype boards. Just like my prototype transmitter on the right side. And by the way, it's also able to control Lego and Meccano infrared controlled vehicles. If you like this video, hit the subscribe button and turn on notifications. Bye!